Okay, here's our notes number 4, volume of prisms and cylinders on page 81 and through 83. Write that down, please. Okay, on your paper, postulate 27 is the volume of a cube. Remember, a cube has all sides equal. And easy way to know it is just do the V equals S cubed. Or you can just do S times S times S if you want, which is sides for that one, okay? And the postulate 28, volume congruence postulate, says that if polyhedras are congruent, then they have the same volume if they are congruent, okay? On 9, it just says the volume of solids is the sum of the volumes of all its overlapping parts. So it's like if you had two parts, like a solenoid, like if you had a cylinder with a cone on top of it, the volume of the top and the volume of the bottom added together would be the volume of the whole thing. On theorem 12.6, volume of a prism, it just has here the actual formula. Volume equals base times height, where B, the capital B right there, is the area of the base, and H is the height. This could also be used what you had back in about 6th grade for the prism of actually a rectangular prism. They use length times width times height. For anything that looked like a box, you use this. But if I have different types of prisms, such as a hexagonal prism or a pentagonal prism, then I must use the BH concept. The theorem 12.7, volume of a cylinder, you have the generic formula that is V equals BH, where B is the area of the base, or the one that I'll use where we go ahead and substitute the base as a circle, so it'll be pi r squared h. And there's your letters that correspond to those formulas. On theorem 12.8 is the Cavalier's principle. It says if two solids have the same height and have the same cross-sectional area at every level, then they have the same exact volume. On our first example, we have a right triangular prism. So we're trying to find the volume. That means we're looking at capital BH being our problem that we're working with. The base, we have to identify it. And remember, in a prism, the sides are all rectangles, and then the bases will be the parallel sides that you actually have. That's a polygon. So on this picture, the base are the triangles here. So I'm going to highlight this triangle here in front and realize I have to find the area of this base. Okay, so the capital B is going to be little b h divided by 2, which the 3 is the little b, the 1 is the h. So that means I'm going to have 3 times 1 divided by 2. Well, that's 3 over 2, which is 1.5 is my capital B. And then the height is the actual height of the prism, which is between the bases, so this will represent the height of my prism. This times 2, and that puts me back at 3 feet cubed is my volume. On part B, I have a cylinder. The formula for the cylinder I'm going to use is pi r squared h, where 5 is my r, 6 is my h. So if I plug in my values, I have that written, and if I type in my calculator, I have the pi times 5 squared times 6. I'll push enter, and that gives me 471 39.2 meters cubed will represent my volume. Okay, if I go into example 2, it says the volume of the right cylinder is this value. They give that to you, and they want you to find the value of x, which is my radius. So if I look at my formula that I had, pi r squared h, I know this, the v is 1253. I have my pi, the r is x squared times 10. So I'm going to divide by 10 to cancel out my tens, and that should give me a decimal. If I did that correct in my head, divided by 10 just to make sure, yes. And now to get rid of the pi, I'm going to divide by pi. So I'm going to take that number and divide it by pi, and that tells me that x squared is 39.8842, on and on and on. And now to actually find x, I'm going to take the square root of that 39.884, on and on and on. And that tells me it's about 6.32 centimeters. Okay. Alright, if I look at number 3, this time they give me an oblique cylinder, not a right cylinder. Oblique just means it's tilted over to the side, but the 8 still represents my height, and the 5 still represents my radius. So to find my volume, I'm looking at pi r squared h. So I'm going to have pi times 5 squared times 8. And I'm just going to put it in my calculator. That gives me 628.3 inches cubed for my volume. Example 4, they give us a composite figure, so we've got two things taking place. And if I look at my picture, notice I have a cylinder, a little bitty cylinder inside of another cylinder, so this will represent a hole that actually exists in your picture. Just like taking a tube and cutting an edge in. So I'm going to find the volume of the big cylinder. I'll put a B right there for the big one. Pi r squared h. So that'll be a pi, and of the big cylinder the radius is a 3 and the height is 7. Okay, and I'm going to save the pi for later, so I'm just going to do 3 squared times 7 and realize that this is 63 pi's. And now I need to do the volume of the smaller cylinder, so I'm going to put an S there for the smaller one, using the same formula because it's still a cylinder. This time the radius appears to be a 1, and the height is still a 7. So this will look like 7 pi is the volume of the smaller cylinder. And since the smaller one is inside the bigger one, I'm going to assume that I have to subtract these two values. So I'm actually going to do 63 pi minus 7 pi. Okay, which is 56 pi, which I can actually calculate that and see that it is roughly 175.9 millimeters cubed. Okay, here is your independent practice problems. I want you to work these, and I'll be back. Let's see, let's do 1, 2, 3, 4, 5. I'll be back in 15 minutes to work the problems and see if you got them correct.
live in Texas. If you've worn shorts and a parka at the same time, you might live in Texas. Huh? If you've had a lengthy telephone conversation with someone who dialed the wrong number, you might live in Texas. Yeah. If vacation means going anywhere south of Dallas.
Okay, if you got these correct, if you look at them, number 1 was 220 meters cubed. Number 2 was 1017.88 feet cubed. Number 3 was 10 centimeters. And number 4 was 1763.01 millimeters cubed. And then on number 5, you had to add the top to the bottom, 25.13 plus 64, added all together. The total volume should have been 89.13 inches cubed. So if you got all of these correct, then give yourself a smiley face and or a check mark, either way, saying woohoo, you got it right, yay. Okay, so that when they know that you got these correct. This one was easier than the last one we did. This is easier because it's volume. So I really miss you guys. So I'll see you on Tuesday next week. So I'm looking forward to seeing y'all. So y'all have a good weekend. Bye bye.